So now we have some fractions, everybody's favorite. And we can look at this as a perfect square trinomial. What we're going to do is we're going to solve this by factoring. And we could use the traditional method. You know, if you're going to use factoring, if I was going to use my x method, I could say, all right, well, what two numbers multiply to give me 1/4 and add to give me 1? And those two numbers are going to be my p and my q. And you might be able to figure this out and say, oh, OK, well, this makes sense. I can figure out what two values multiply to give me 1/4. But a lot of times when dealing with fractions, it gets a little difficult with students. So I'm going to kind of show you looking at this and actually understanding how this is going to be a perfect square. Now, our previous method was finding our c and determining which perfect square it was. But you can see 1/4 is not one of these perfect squares up here. And the reason being is these are all perfect squares for my integers. But now we're dealing with fractions, which gives everybody chills when they're looking at them. So to solve this, to look at this, what I need to do is say, all right, what is going to be, if this is a square number, then therefore I can take the square root of it, right? So, and remember, we want to take the square root because if this is, if here's my c, we have two numbers that multiply to give me c, which is going to be, let's just use p times p. Those two values give me the square root. And then our coefficient of our linear term needs to be this 2 times the square root of that. So let's go and take the square root of my c, right? Because this is c. And remember, c as a perfect square can be broken down into p times p. Remember, all these letters are just representing numbers, where c represents my constant. So let's take the square root of 1/4. Well, the square root of 1/4 equals the square root of 1 over the square root of 4, which equals 1/2. So therefore, I have 1/2. Well, 2 times 1/2, that's going to leave me with 1, which that is that coefficient there. And then I check in, does 1/2 times 1/2, does that give me 1/4? And yes, it does. So therefore, I can see that my p and my q, or my two p's, because they're exactly the same, I should actually rewrite this for my perfect squares, are going to be the same. Now, since this is a positive one, I know that my 1/2 and 1/2 both have to be positive. So since we're solving, we're going to set this equal to 0, and then I'll write x plus 1/2 times x plus 1/2. Now, to finish solving, I can, I'll just use the zero product rule for this. I'll just set both of them equal to 0. But since they're both the same, we don't need to solve both of them. So I'll just solve one. And x equals -1/2. And we'll learn about later on why, when there's two solutions, what does that do to our graph and what does that look like. But you can see our x-intercept is going to be x equals -1/2. That's going to be the solution to the quadratic, roots of zeros, depending on what your question is asking. Thanks.